Guys, now your topic is strain gauge. And just I will take 10 minutes. We know this is the strain gauge. Look, this is also this is a strain gauge. This is made of actually this is called load cell also. And now a strain gauge is generally measured the strain, means it is a typically a resistance, but whenever a force is applied over this resistance, then what happens? And the resistance value of a resistance will change, and this change of this resistance hence will measured by a electrical or electronics device. Then it will we can measure any strain or any force. So strain gauge is basically comprised of a this cantilever form, and this cantilever is fixed one side and another side is free. If we apply some force just like this, then what happens? This cantilever became deformed, means deformed just like it is bending, and whenever it is deformed, then then some force will be exerted at this strain gauge. This is the strain gauge, and whenever force is applied, so it exert a stress. Whenever stress is applied, then what happens? The resistance we know, rho r equal to rho into L by A. So if there is a change of any length, then the resistance will be also changed. So if there is some strain is there, then the resistance also change. So if we can measure this resistance, then we can also measure this force, because at that moment force is applicable. Change of force is proportional to the length of the or the resistance. So we can measure the resistance, and we also can measure the force. So now what is the construction of this load cell or the strain gauge? Look, this strain gauge is just like a Wheatstone bridge formation. Say this is the one arm, this is the another arm, and this is the, so here is the deflection also there. And now if we apply some voltage, then what happens? If any change of this arm, what happens? So deflector will detect, and this detection can say then use as a change of force, or we can measure the force, because first time force is normal, there is only air pressure is there. Then if we apply some force, then this cantilever became deformed, and due to this deformation and this all resistance, here is a strain gauge, here is a strain gauge, here is a strain gauge, and here is also a strain gauge. So if this is strain gauge, fourth strain gauge is over there, here is a strain gauge, here is a strain gauge, and here and here. This is completing the four arms. This is the R1, R2, R3, R4. So this is R1, R2, R3, and R4. So in this way, we can measure the force by using this Wheatstone bridge. So here in the upper side, compressed force is working, sorry, tensile force is working, and in the lower section there is the compression force is working, because look, this is compressing and this is tensiling tensed, and in this way these two arms of this Wheatstone bridge will change its resistance due to the tensile force, and the lower arms of these two resistance will change its resistance due to the compression force. And this way the deflection will detect what is the exact change of the resistance. And in this way, if we can measure this resistance or change of this resistance, then we can measure also the force. So this is the working principle of the strain gauge. Now, what is the material used for this strain gauge? Generally, the nichrome wire is used for this material, for this resistance. And what is the construction of this cantilever beam? This is made of alconel. Okay, this beam is made of alconel or the karma alloy. And look here, the two holes are there. Actually, this is the specification of this is cantilever beam. You, if you see this type of hole is there, then you can easily understand this is the strain gauge. Because if we don't provide this hole, then the uniform deformation will not occur. So whenever you go for any strain gauge, look, as per its range, it will increase one by one hole, then one space, then another small hole, then another space, again another small hole, then again space, then another big hole. This is the special cutting of this strain gauge. Okay, and now this strain gauge is cementing over this cantilever beam by some cementing material, just like epoxy resin. This is looks like a white color of resin, and this is called the epoxy resin. And these four arms is connected with this Wheatstone bridge. Okay, just like this, you can see this four arms is connected over here. So if any change of resistance, then it will detect, and this detection implies that it is a force. Okay, so this is the strain, all about the strain gauge we are using for our general local purpose weight machine, normal industrial weight machine, etc. And this strain gauge is also applicable for the torque measurement. Say this is apply for any drum shape, and the position is that here this is in this horizontal shape, and this is in this shape. This is vertical, this is horizontal. And in this way, if we apply some strain gauge over a rotary device, if I if we apply some rotary device, say it is rotating, then it will also measure the torque. So the torque measurement, we also use this strain gauge, and this strain gauge also attached with a Wheatstone bridge, and any deflection occurred by this rotation, it will detect it by this Wheatstone bridge deflection. And this deflection maybe going for the any amplifier section, then it will amplify the signal, then we can measure just like the instrumentation scheme. Then it will go for the signal conditioning. After signal conditioning, it will go in for the MC unit, means microcontroller unit. Then it will go for the either controller or the recorder or the visual display unit. So in this way, we can measure the any force or torque by this strain gauge, or it is totally called the load cell. This is called load cell, and this particular cell is called the strain gauge. Okay. So guys, if you have any question, you may ask me. Otherwise, I'm going to stop here.
It's okay, sir.
Okay, okay. Then I'm going to stop here. Okay, thank you.
Thank you, sir.
Thank you.